All right, let's now have some reminders over here. For your programming test 1, I know it's gone, but if you still want to discuss your solution at any time, drop by my office hour, we can talk about it. It might help your programming test 2. For your lab number 3, just remember it's due Wednesday, next Wednesday, I believe. Okay, not this Wednesday, next Wednesday, right? So just make sure, once you learn about the copy constructor today, you're fully ready to really get it done. It should be more straightforward than lab 1 and lab 2. It should be. Hopefully that you can see yourself growing on being better on the OOP. And for your written test number 2 that was taken yesterday, I'm gonna release the result by early Friday, maybe more likely tomorrow, but the latest will be early Friday. So you can take a look and maybe speak to me if you got any concern. And for your programming test 2, that's gonna happen next Tuesday, I'm gonna give you guys some guide. But you can assume it's going to be very related to your lab number 2, based on lab number 2. I'll make it more precise and give you some hints about how you can practice for that, all right? All right, do you guys have any concern before I move on to contents? We're good, right? Okay, good. So the plan today, I want to give detailed response to one of the questions you guys asked me about private attributes and also dot notation. I believe it was Marcus who asked the question, but he's not here just yet. But he will see that later. And then I'm going to finish the topic about composition, mainly the issue of copy constructor. And then we're going to move on to inheritance. It's a big topic that we're going to spend quite a bit of time on discussing it. It's a whole story to tell. We'll get there, one step at a time. All right, I want to start with this. And this was the question that was asked back on Monday. If you remember the second exercise we did for aggregation, we talked about the dot notation. For example, let's say we are now currently in the class of course. That's a context, that's a starting point. So for this particular get title, we say this get prof, for example, and then we say get TE, right? So because this get prof is actually going to give you the faculty class. And if you go to the faculty class, and then you can see you got TE over here, right? And Marcus' question was, over here, can we say also TE? So here the correct solution would be get TE, but can we also say TE over here? And notice that TE is a private attributes, all right? The answer is you cannot. It's going to be a compilation error. However, I would like to talk about this more thoroughly so you actually know the principle and we can do some exercise as well. It's actually quite an important issue to deal with because your attributes are most often just simply private. You have to know when to use them and when not to use them. All right? Let's talk about it. And so this will be a little bit contrived example, but I think that one pretty much explore the possibility you might have. Let's take a look. Let's say we got two classes, class A, and also we got class B. Class A here, and class B here. And the way I declare the attributes are pretty symmetric. You can see here in A, we declare some reference variable called OB, which can let us navigate to B, right? Symmetrically, you can see for class B over here, we also declare OA of type A. That means we can use this attribute to navigate to class A and vice versa. Okay, that's the intention. And we also got another attribute here, also private. All the attributes are private, which is called AI. You can think about integer in A. And also here we got integer in B, right? So we got two attributes in each class. And what we don't want to know, just before that. And also we got public accessors over here. You can see in class A, we want to have one accessor for getting the B. So just return this.ob. And also we got one public accessor for getting the AI, the integer, so return this.ai. Similarly, we also got these two public accessors for retrieving these two. And then we have this particular method here in the context of A, right? Let me notice the context. So this method here is defined in the context of A. Let me just use yellow. This method here is defined in the context of A. And we want to consider all these dot notations. Some of them compile, some of them wouldn't. And we ought to know which ones, all right? And I think I'm gonna maybe save everybody some time. Let's talk about the principle, and then I'll do a few together with you, and then we can have you answer maybe a few, and then that will be it. Okay? So here's the principle. The principle is, if you actually want to say something, if you want to say some context objects dot some attributes over here, if the attribute over here happens to be private, in some cases you can do it, in some cases you cannot. When can you do it? You can do it if the type of the context object over here matches the class where you're writing this expression. Okay, let me make it more precise. Think about you're writing this particular expression over here inside the context of, let's say, class X. Right? And this line here might just appear in some method under class X. You want to check to see if this particular context object over here, let me just make it different color here. Let's say this particular context objects of type, let's say Y. All right? And if Y and X happen to be the same, in that way, you can use the private keyword. You can use the private attributes. Otherwise, you cannot. That's the principle. It's a bit abstract, but I can tell you the principle first. So you're going to say, if X equals Y, right? Then, okay to reference the private attributes. Otherwise, you cannot. Right? That's the principle. First of all, get the conceptual idea straight. Right? Let's now try to use this principle here to judge. Okay? Let's look at each one of them. This one here, we are referring to AI, which is private. What's the type of this? A. A itself does have this private attribute AI, so that's why we can do it. All right? The type of the context object is exactly A, which matches the context class, in which case we can refer to AI. The first one is easy. Let's do something just as a warm-up. And what about this one here? Well, this one here is not an issue because you simply say calling the public method over here, get AI. So that's not an issue, right? So that one should be okay too. So far, so good. What about the next one? This.ob, is it okay? It is okay because OB is private, true. However, this is of type A, which matches the context class, in which case this.ob is actually fine. But what about this.ob.bi? If I say this.ob, it allows me to go to class B over here. But can I still refer to bi? That's the question. According to the principle, we cannot. All right? That's really important. Let's make it clear. If you try to analyze this particular dot notation, think about this part over here is the context objects. All right? So this is the context objects of type. This.ob is of type B. And can I refer to the private attribute bi in B? I cannot, because B does not match the context class over here. So you cannot. That's why. All right? Guys, hopefully it's getting better, right? So you cannot. Because the context class A does not match the type of this.ob, so you cannot. All right? If this doesn't compile, the only way around is to say, rather than this.ob, I can say, oh, actually, sorry, let me just say one more. Can this work? By following the same principle, this also cannot work, because if you look at that over here, this.get B over here, what's the type of this.get B? That one there is going to return B. And B also does not match A. So you cannot refer to the BI, which is private. Also, you cannot. And Marcus, I'm just talking about the question you asked me the other day. You can catch up with the recording later. Yeah. All right, so also this one wouldn't work. So the only way around, if the context object type does not match the current class, I mean the context class, the only way you can refer to a private attribute is by using the corresponding public accessor. That's the only way. So now if you say this.ob, again, is referring to B, and the only way I can do it is by calling getBI. That's the only way. All right? So this is actually OK. Any question so far? For those of you who just came a little bit later today, I still appreciate you come. But for the part I just started, you may want to catch up with the recording. It's actually a very important subtlety you want to catch up for. All right, any questions so far about this? We can do just maybe a few more, and then I'll leave you to study that later. Are we OK so far? OK. Let's now try the following. Let me do this. Can I just say, let me call this 1, 2, and then 1, 2, and 3. OK, how about this? 1, 2, 3, and then, how about the 1, 2, 3? And then for the rest, you can also judge its exercise. For 1, 2, and 3, any one of them does not compile. 1, 2, and 3. Marcus, even though you came in the middle, you want to give some try? 1, 2, and 3. How about let's go one by one. For number 1, do you think number 1 is OK? How do you guys think? Number 1, in some way, is pretty safe because you're only calling the public accessor on the context objects. So that's not really the issue. So when you say this.getB, that one there is going to return B. So you go to the B. And then getBI, you just call the public method here. That's not an issue. The only tricky point comes in if you try to invoke private attributes. Okay, so this one, number 1 is OK. It's pretty straightforward. Number 2 is important. All right, number 2. We are ultimately trying to refer to AI. AI is private. Is it going to be a compilation error here? Jasmine, you said no. Can you tell us why? Oh. Pretty much, yes. Mm-hmm. Yep. Absolutely, absolutely. So here, let's take a look. You can see this part here. This is the context objects for AI, right? This is the context objects of AI. And the context object here, this.ob.getA, this.ob is going to give you B. B.getA is going to give you A. So you're back to this particular class, right? So context object is of type A. Number 1, which matches? Matching. Where are you writing this line? It's in the context of A. So both match. So in that case, you can do it. All right? Matching the context class A. All right, so what I want you guys to do is to really compare this line here, where we are referring to private attribute BI, and also this line over here, where we try to refer to private attribute AI. Why one does not compile, but the other one does, right? Which I explained already. And for the rest, you can think about in the same way. I'll leave that as exercise. If you're still struggling, speak to me. I'm pretty sure this might appear at some point in your assessment. All right? Hopefully that will push you a little bit. to study. And just to make your exercise even easier, I am also going to make the source code available to you. So the A and B, you will see that over here under the A. So these are all the things I just talked about in the notes. You can give a try. And also where the attributes, for example, is underlined with red, so that says it's not visible, which means you cannot really get access to it. All right? Play with it. You can feel free to create more classes and also more examples to see which one should compile, which one should not. But the guiding principle is really what I said and illustrate over here. That's something you want to keep in mind. All right? I'm pretty sure if you try another OOP language, for example, like a C#, they also support pretty much like a Java construct, private and also public. They will follow the same principle as well. So it's not just for Java. Okay. Yes, question? Sorry, can we? What do you mean want to? Oh, sorry, I don't quite hear you well. The third one together? Sure, of course. You mean number 3 here? Okay, no problem, of course. This one here, okay. This one here also is a straightforward case because this is referring to A. This .ob is referring to the private attribute in the same class, which is okay. And that will navigate us to B. And then we say get A. Get A is a public accessor. So we don't need to apply this principle because it's public. Get A is going to give you back to A over here. And then we say get AI. Again, it's public, so we don't have to use the principle. We only apply that principle if you're trying to access private attributes. But if you're only trying to access maybe public attributes or public method, you don't have to worry. It's always possible. Okay, good. All right, guys, I think it's a nice little bonus. I didn't really plan to talk about this thoroughly, for this semester, but you guys got it. I think it's good for your knowledge. And thanks to Marcus. All right, good. And of course, the catch will be, this might be in your exam. Please study that. I think it's good for you. Okay, good. That's the first part. And the second part, let's talk about composition, which is mainly just about copy constructor. And we just need to understand how the copy constructor should look like and what kind of properties you really want to satisfy by the copy constructor. And this will be exercised also in your lab number 3. So you definitely will get an idea. Okay, let's talk about it. The example I want to use is by using the file and directory, okay, over here. And let me explain the diagram very quickly, just to remind you. Oh, okay, let me just point a little bit, okay? So we follow, number 1, you can see the diamond over here. Rather than being empty, like in the case of aggregation, for composition, you simply got solid diamond. That's number 1 thing to notice. Whenever you see the solid diamond, that means composition, meaning that no sharing should be allowed. If there's any sharing or aliasing that might occur, you're violating composition. Just keep that in mind. Okay, first of all, notice this diamond here. And how do we interpret this diagram? The same as before. We got both directions. A directory has multiple, you can see the star has multiple files. Each file has the type file. Right? Pretty consistent. And symmetrically, each file has or contains a single parent directory. That's how you interpret that. All right? Hopefully you're fine with that. And we're going to see how we can implement this simple relation here using Java. And by the way, for those of you who maybe not at this point, you might decide to take the database course in your 3rd year. So in database design, we'll see this kind of diagram called entity relationship diagram very often. So I think it's not really a bad idea to get used to such design at this level, right? Many people actually take database course in their 3rd year. So you will see lots of these. All right, so we assume private attributes, public accessor, that's fine. And then I want to just show you very quickly about the implementation. Let's get warm up first. We have directory, and also we got file. For the directory class, we have a name, and we're assuming that it's just private. Okay? Actually, I don't have space on the page, so bear with me. Private name, also an array of files, and also we need a counter to keep track of it. Straightforward. And for the directory constructor, let's say we do something very standard from before. So we initialize the name, and also we create an array of files. Let's say up to 100. Okay? By the way, some of you actually asked me during the office hour, in this course, do we ever have to worry about resizing the array? Let's say if we want to store more than 100 files. The answer is no, you don't have to worry. In the subsequent course to this 2011 data structure, you will have to worry about how to grow the size of the array. And there are different strategies you can apply. But the consequence, you have to argue mathematically. That's something you will do in the follow-up course. But for this course, you can always assume there will be some maximum capacity. Okay? And then we got add file. And this one here, very straightforward, right? No surprise so far. What about the file class? So file, we got some name of the file. And also just initialize the name. All right? And just one more thing to show to you on the sideway. There, in the directory class, there's also another method called getFiles. And for now, let's say we only just do return this.files. Just return the array reference without creating any new array. How to create that new array, I list that as an exercise for you at the end. Okay, for now, just assume we just say this.files. Just that. All right? That's the implementation. And to begin with, I would like to show you a very simple JUnit test method just to see how things work before we talk about copy constructor. Right? So that's what I just went over. And what I want to do now is to create a directory structure like this. A directory with name D, which contains F1, F2, F3, 3 files. Straightforward. Why don't we take a look? Let's try to visualize it. So here, let's do one by one. We create a directory, D1, with the name D. D1 is pointing to a directory objects, and the name is D. And then we also try to initialize the array, as you can see, of size 100, so from 0 to 99. Initially, every slot is null. Okay? And what's going to happen if we say d1.addFile 3 times? That one should be no surprise. We simply try to add different file. For the very first time, we're going to create a local file here, and then it has the name F1. F1 over here, right? You can see f1.txt. And then index 0, oh, by the way, initially NOF should be 0. By adding the first file, it's going to point to here, and then increment from 0 to 1. Are we okay with this? Right? And what about the second one? Similar, because now NOF is 1. So we're going to store the second file here and increment from 1 to 2. Finally, another file, index 2, and then 2 to 3. Very straightforward. What we should notice now is so far, composition is okay because for this file here, it has only one parent directory. We didn't really have a case where there's another directory here which has an array of files, but somehow the file points to maybe here, in which case we got aliasing. Because for this directory, it stored this file. For this other directory, also stored this file as well. That's something we would like to avoid. But so far, we haven't got that issue just yet. I'm going to create that very soon. Okay, are we so far okay? This part is here just to remind you about the programming pattern that we have been programming since forever. All right, this one is pretty good. And let's now talk about copy constructor, right? Let me give you a little bit of abstract idea about the syntax for a copy constructor. Apparently, it is a constructor, but it has some very special shape. Okay? Let's say, for example, I have a class called X. Let's not worry about public. Okay? And then every constructor in the class must have the same name. We know that pretty well. And of course, the default constructor wouldn't take any parameter. Some other constructor can take as many parameters as you like. But for the copy constructor, it has the following rule. It must have exactly one parameter. And the type of the parameter of the copy constructor must be matching the context class, meaning that it should be exactly X. For example, other. And then, of course, you might do some stuff over here. All right, so this is how you should remember what a copy constructor is. It's a constructor, but has a very special property. Okay? This is called the copy constructor. Again, copy constructor has only one parameter, but its type matches the context class. All right? Knowing this, what we have to do now is to really have a copy constructor. You can see directory, constructor name. Also, directory parameter type matches the directory context class, right? Exactly what I just said. What we want to do is to implement this copy constructor here such that we can disallow any potential sharing of the files inside the directory. That's what we would like to achieve. And I'm going to give you some wrong version first, and then we're going to see what the correct version should look like. Okay? Okay, so we definitely just want to, well, you can read the hints later. Why don't we just go there directly? And version number 1, I can tell you first of all, is wrong. It's something simply called a shallow copy. Well, I have the notion between shallow copy and deep copy. Thinking this way, shallow copy, you try to copy reference. Deep copy, you try to copy every object you actually have. That's one way to look at that. But let's look at the shallow copy directly. Okay, let's say we have this directory here, and this is a copy constructor. All right? And first of all, I copy other.nof. Just copy the integer. So this is to say for the current objects, the context object, its NOF, is going to copy the value from other.nof. That was easy, right? What about the array? The name will also be a copy of other.name, and the files is also assigned to other.files. I want you to focus on this line over here. Let me switch. I want you to focus more on this line. This one here. This one here, is it trying to create a new array? Not really. You don't see any new keyword. Whenever you don't see any new keyword, that means no new object has been created, number 1. Number 2, what exactly is it trying to do? Don't forget, an array has many objects potentially. What exactly are we copying? Are we copying the reference of the first elements in the array? Or are we copying the reference of the second element in the array, or something else? That's the question. Okay? It turns out this assignment over here is copying the beginning address of the array. All right? I'll write it down, and then we'll visualize it. That's so important. Copy the beginning address of the array. That's what we're doing. Let's see how we can visualize it. I got another test case for over here. I will just test the shallow copy of the constructor. Let's take a look. Okay. We still have a directory called D1. D1 over here, right? Initially, it has 0 up to 99. And then we are trying to add 3 files, F1, F2, F3. That's something we traced earlier. So you can see F1 here, F2 over here, F3 over here. Up to now, we have done that already. And let's see how we can use the copy constructor over here. New keyword, constructor. The argument type, D1, is directory, which matches the object that we are creating. So we are really using a copy constructor. Are we okay with that? Okay. So you can think about this one here is calling the copy constructor. Okay. And let's see what the consequence is for creating this D2. What it does, of course, it must create D2 objects. Let me do that. I have D2, which is pointing to just a brand new objects, for sure. And then, when I trace this copy constructor here, I have to go to the copy constructor, which is over here, right? And I'm going to execute line by line. Number 1, I'm going to copy the NOF. The NOF of this copy constructor, of this new object here, should copy other.nof. And in this case, what's other? Other is D1. and other here is D1. And by the way, when you look at argument passing, think about call by value, which we spoke about already, right? I want to just remind you. So here it's D1. So this NOF should be D1.NOF. So this will be copied to 3. That one is easy. What about this part? The D2.name would be D1.name. D1.name would be just D. So D2.name is going to just point to the same string objects, the same address, right? What about this part? This part here is going to be, let me write it down. When we see this dot files is assigned to other dot files. That's the declaration, that's the definition. And in this case, since we are having D2 as the this, and we're having D1 as the argument, so that'll be other. All right, let's now trace it. D2 dot files is referring to this particular address we have to store to refer to the beginning of that array. Now it's going to copy over the address that's actually referring to the beginning of D1.files. What's D1.files? D1.files is referring to the beginning of this array, this pointer over here. How do we visualize it? That means this part here is going to point to just the beginning of the same array, like that. That's what's happening. I will pause a little bit. I'll let you guys digest. Are we okay with visualizing the array copy? We're okay, right? Okay, it's really important. Okay. And now, is this really satisfying the composition? Well, as long as you got some aliasing, you're not really satisfying composition. Because D1 and D2 over here, they are pointing to the same files array. What does that mean? That means even though D1 and D2 are different objects over here at this level, but at the next level, for the array of files, they are really referring to just the same file objects. Meaning that if I try to modify, for example, the name over here, it's going to impact both directories. So they are not exactly independent of each other. So that's violating composition. Just remember, composition goes very extreme. You cannot have any sharing or aliasing. Okay, just remember that principle. And let's double check that. If you go to the next line, here, if I say D1.files versus D2.files, this one here, equal, should give you true. D1.files is referring to this array. D2.files is referring to the same beginning of the same array. In that way, this will be just true. All right? And this assertion here proves that the violation has happened for the composition. That's what you will see in the slides. And let's see even more. If you ever have, let's say, changing one directory, if that can impact another directory, that also can prove the violation of composition. If I say D2.files at index 0, the first file, I want to change its name to be F11, let's say. Okay, what does that mean? That means I'm going to do the following. So D2.files at index 0, D2.files, which will refer to this array over here at index 0. That one there should really refer to this file over here. And I want to change its name to F11, F11.txt. That's what I do. And if composition was satisfied, that would mean D1 and since I'm only changing D2, but if composition was satisfied, D1 at this position, the file should not be modified, but it was. So that's why it's violated, right? So let me just make a note over here. D1.files.equal. So this condition here satisfies if composition was preserved. Was preserved. Again, why? Because if you look at that, we are trying to change the file for D2. So D1's file should be unimpacted, should not be influenced. But it turns out, if I try D1.files at index 0, I'm also referring to the same F11, right? So that actually shows that the assertion is going to be assert false, right? So that condition there is not really satisfied. So violation for composition. Is it clear about what's going on here? I hope. Any part that's confusing? All right. I take silence is okay, but you guys will study and struggle a bit and come to me. Okay, so how can we resolve this? The way to resolve this, I'm going to show you the code. You can feel free to reuse it for Euro Lab number 3 and also in the programming test, that's fine. It's a very standard way of doing things. So without diving too much into 100% detail, which might be a little bit boring, but I will just highlight what you should really notice. Okay. Deep copy. So now, the shallow copy wouldn't work because even though we got 2 different directory objects, but they are really referring to the same array of files. So what we want to do is to say, not only that we want to have 2 directory objects, but also we want to have 2 separate arrays. Not only that, each element in both arrays should refer to different objects for the files. We want independence, no sharing at each level. That's what we want. So that's what the deep copy will do. So let's now go over a little bit, and then I'll let you guys study the code and get back to me if you got any trouble. And the way we're going to do it is we want to define copy constructor in every class. Okay? The easiest way or the most effective way to really implement composition is by introducing the copy constructor for every class that should be relevant. In this case, the file and the directory. Both of them should have the copy constructor. And this is what we do. In the file class, we define this copy constructor, right? Here you see file, file, and file. It matches the syntax for copy constructor. And the only attribute we have for the file is the name. So we just copy its name. So we don't really say this.name is assigned to other.name. We don't do that. We are creating a brand new string object. That's something might be you haven't done so far. All right? Notice that one thing. And what about directory? The directory here is a little bit tricky. So I'll go over line by line with you, and then we'll do some tracing. So that's the file that we just talked about. And let's now talk about the directory. Okay? So we have constructor here. Oh, actually, by the way, we got 2 constructor. Apparently, this one is not a copy constructor because even though it only got 1 parameter, string does not match directory. So this is not copy constructor, just an ordinary one. This one here, what does it do? It will simply just copy the name, and also it's going to initialize the file to be of certain size, pretty much like what we did earlier. And this will be the actual copy constructor we have to worry about. Let me explain line by line first, and then I'll trace a bit by visualizing. And this, I think that this is something I mentioned in the tutorial video in the first week, I believe. If you put this as the first line, okay, so that means you're calling another constructor. In order to define this directory over here, we are calling the other constructor. The other constructor will simply take a string other.name. Which one is that? Exactly this one. It's as if we try to put these 2 lines in place of this. But a better style would be to define maybe these 2 lines in a separate constructor and then call this over here as a helper method, right? It's not really required, but that's something very useful. Many developers do that, so you can consider doing that as well in your Lab 3 just to practice, all right? And what about this part over here? And guys, I will let you stare at this just for 1 minute, as usual, and then we'll talk about it. Not many lines, but you ought to kind of picture in your mind what's going on here. Okay, another 20 seconds or so. Or maybe think to yourself, why would this loop over here with the blue, pink, and orange line, why would it do the trick by satisfying composition, but not the previous version where it would simply say this.files equals other.files? That's really what you want to convince yourself about. Okay, let's now go over that very quickly, and I'll visualize it. And then I have some exercise for you to consider, and then we're done for composition. Apparently, we are trying to go for a loop. Go from index 0 until less than NOF. So that means depending on how many files there are in D1, in this case, 1, 2, and 3, the loop is going to run for 3 iterations, number 1. Okay? And then let's look at these 3 lines. They're not too bad. Okay? First of all, we're going to create a new file. Oh, sorry, let me say it again. First of all, we're going to create a new variable over here. And that variable is simply just an alias of other.files at index I, which can be 0, 1, or 2. And then once we get a source over here, we're going to call the copy constructor of the file, which we have already seen over here. So this one effectively just create a separate copy of the source, which makes sure there's no aliasing, right? And once we got this new file over here, we're going to add it into D2. That's it. And we're going to do this for as many times as required, depending on how many files that need to be copied. All right? So these are the 3 lines. All right? Why don't we try to visualize this a little bit? And then you really want to convince yourself this is right, it really is doing the trick. Let's try. So let's start with, let's do this test over here. This part over here should be no surprise to you. We're just creating D1. Right, this part here, so you can see D1, 3 files, 0, 1, 2, F1, F2, F3. Right, that one's pretty easy. And this line here, we are calling this new version of the copy constructor. Right? Basically, we're copying D1 and store that into D2. That's what we're doing. Okay? And in order to execute this copy constructor over here, we're going to go into this version over here. The first line is calling this helper constructor over here, as we said. Right? That one there is simply going to create a new name and also create a new array. Okay, let's do that. So we got D2 over here, and then the name over here is going to be just a new copy of the D. As opposed to, you can see, used to be the name, and this name here point to the same string object, not anymore. All right? So that's about the name copy. And then we're going to create a new array over here. So that one is already different from the shallow copy. So here we got a new array over here. So go from 0, 1, 2, all the way to 99. All right? So that will be the effects just for this line. Are we okay with this? Okay. And let's run the loop. How many times of the loop should we run? It depends on what the this.nof is. This, indeed, is, it depends on what NOF is. In that case, we want to actually copy, you know what, there was a little typo over here, I believe. I'm going to fix that, okay? The NOF here, you got to be careful, okay? Because we want to copy from D1 into D2, right? At the moment, D2 has the NOF simply 0 to begin with. But you got to be careful. Since you want to copy from D1 to D2, you ought to use the NOF of D1. Right? So this is a very terrible typo. I'm glad I noticed that. So here, it should be other.nof. All right? I'm going to fix that for sure. And other.nof, it will be D1.nof, which will be 0, 1, and 2, right? So let's now run this iteration here. We're going to create a source for the first iteration. So the source is actually going to point to other.files at index 0. And other, don't forget, is D1, right? D1. So D1, the files at index 0 will be this file over here. So the source is going to point to here, first of all, the source. And then the next line there is actually going to copy the source. By the way, the source itself is not yet a brand new copy. It's only an alias. We're going to use the source to actually pass into the copy constructor for the file. All right? And how do we execute this line here? Well, according to the file copy constructor here, you're going to create a new file object and create a name. Okay, let's do that. And that one there, source is pointing to this file with the name here. So we're going to create a brand new file object over here, and then it's the new file pointing to here. So we have the file, and then it has the name, which would be just f1.txt. You can see so far there's no sharing. Okay? Finally, if you look at this line here, it's actually going to add this new file over here into D2, right? And what do? Index 0 to here. That's what it does. And that's only the first iteration. Okay, the detailed tracing is done. Let me just draw what's going to happen after all the other two iterations. The second iteration is simply just going to change the source rather than pointing to here. It's actually going to point to the second file, which we want to copy. And then we're going to create that file. And then the name will be just a copy of f2.txt, right? And then this will be the new file. So the new file is actually pointing to here, right? We're just executing this once more. And then we're going to add this file into D2. So this one here is actually going to point to the new file. So far you can see we got one file here and one file over here. This versus this, they are basically copy of each other. There's no aliasing. Also, this file versus this file here, there's also no aliasing, right? Okay. And of course, you can also do the third iteration. That one should be straightforward, so I can skip. All right. Let's now take a look at the assertion. If I say d1.files not equal to d2.files, that's true, because d1.files is referring to this array. d2.files is referring to this array. So as far as the array themselves are concerned, we are satisfying composition, which was not the case in a shallow copy, right? So this part here is really good, preserved. And more to it. Let's say I'm now trying to use D2 as I did before. D2, I'm trying to use the D2 over here to change the file at index 0, which is over here. I want to modify its name to be F11. Since I try to change from D2, is D1 file going to be changed? Apparently not, because you can see I'm only modifying this file over here, whereas this file here has nothing to do with it. So that's really indeed composition. Changing one copy does not really impact the other. That's really the spirit of composition, right? So that's why this will be assert true rather than false if you compare with the shallow copy version. All right, so that's about the correct solution for deep copy. And for your lab number 3, of course, it's not really about file and directory. It's about something else. And we might have more than 2 classes for you to worry about. And what you just have to remember is, in order to really implement composition, you have to introduce copy constructor at each level. Always think to yourself, am I allowing any possibility of aliasing or sharing? If I'm not, then most likely composition will be okay. Okay? Any question about this? Okay? And one little exercise for you. Now, I want to do somewhere between shallow and deep copy. I'll show you what I mean. That'll be an important exercise for you. You will see also the solution in the slides. Okay? I want you to compare this alternative version for the copy constructor. Let me show you what change I have made. All right, don't lose the big picture. Shallow copy does not satisfy composition. The deep copy, it does satisfy composition. But now I'm introducing somewhere in between. Okay? This one here used to be the correct version of the copy constructor for deep copy. I'm deleting one line. Rather than, well, once we get a source file, the alias, right? Rather than calling the copy constructor from the file class, I'm directly adding source into the directory. That's the change I'm making. Now, does this still satisfy composition? Most likely not, because it sounds like we are sharing something, because we are not really making copy of the file. All right? For this one here, I'm just going to give you a little bit hints visually, but you ought to think about why it wouldn't satisfy composition anymore. Okay, I'll give you a little bit hints. Okay? For this one here, okay, so what's happening here is we still got D2, right? So think about this line here. This line is going to be executed. We still got D2, and the name itself is going to be a copy. That's not an issue. The NOF is also going to be 3. Okay, that's not an issue. And also, for this line here, we're going to initialize the array over here. Also not an issue. 0, 1, and also 2, etc. until 99. All right? And what's going to happen here? Source, what's source? For the very first iteration, source will just be pointing to the file at index 0 for D1. And I'm not really trying to make a deep copy of the file by calling the copy constructor in the file class. I'm not trying to do that. What I do instead, I'm passing source directly to the F file. Right? So what's happening here is 0 over here is actually going to point to this file. So we do have some sharing. Number one, we don't have sharing at the directory level. Number two, we don't have sharing at the files array level. However, we do have sharing at the individual file level. That's the problem. Okay? So what you guys want to do is to go over these assertions over here and convince yourself. Those actually show in this intermediate version, it violates the composition. Right? Let me finish the visualization, which is pretty easy to do. In the second iteration, 1 is actually going to point to 1 here. 2 is also going to point to the 2 here. So we do have sharing at the file level. And these assertions are going to prove that the composition is not really maintained because you got some sharing. Meaning that if you try to modify this file over here, it's going to be impacted this file as well. Right? That's really something you want to do for this exercise. Right? I've already pretty much tell you everything you should know, but you should really study that more concretely yourself. Okay? Any question? Yeah, so far we talked about aggregation and composition. Just remember, aggregation talks about sharing. Composition talks about extremely forbidding sharing. Okay? A few more slides just to compare these two mechanisms, just to know, have some idea when to use which. Okay, let me just watch out the time. Okay. All right, so there would be, okay, that's the exercise we just talked about. You're going to go over them. And this will be some exercise for you. Actually, you got something very similar in your lab number 3. What I said earlier was we assume the get files method over here. That one there simply return this .files. That one there does not really create any new array. It simply returns its beginning address, like alias. That's not good. Your exercise is to see how can I instead create a brand new copy of the files array and make sure there's no sharing. That will be your exercise. All right? You're going to use a very similar loop, as we said. All right? That's the exercise for you. And the final bit is to compare these two mechanisms very quickly, okay, by using some example. All right? So we talked about container, containee, right, last time. And also aggregation is really about allowing sharing, right? So these properties, also we spoke about them, just repeating, so you can review the slides later. Composition, no sharing. Okay? And let me give you some more example. Oh, aggregation composition may exist at the same time in your project. Maybe certain parts you have to use sharing. Other parts you may want to forbid sharing. It depends. There's no really extreme. Okay? Let's say workstation in the person lab. Okay? So which part can be composition and which part in your person lab can be aggregation? Think about what can be shared and what cannot be shared. Right? For example, CPU, monitor, keyboard for each workstation, it belongs to just that workstation. You cannot really share the keyboard from your neighbor, right, in the test or in the lab session. So they are more like compositions. What can be aggregation, though? Can you think of what can be aggregation? What's really being shared from all the workstation? Keyboard cannot be shared. Monitor cannot be shared. But what can be shared? Sorry? The website? Yeah. The server, right? The server is being shared, the network. Very good. Okay? Yep, straightforward. Yeah, I could have just told you guys the answer, but I thought it might be nice for you guys to think about, the same network. You can think about other examples too. Right, so that's a little diagram over here to show to you. Okay, I'll just point out some highlights for you. Okay, give me a moment. Oh, here, all right. Workstation number 1, workstation number 2, workstation number 3. Each one of them has their own keyboard, right? So you can think about this part over here, they are not being shared. So that's more like composition. On the other hand, all the workstation is connected to the same, maybe red server for you guys, or maybe Indigo for the more staff member or faculty member. In that case, they're really sharing the same network. So for that part there is aggregation. Straightforward. Which means if you want to really implement this particular architecture, you want to know which part should be aggregation and which part should be composition, of course. Okay, straightforward. And I have a little exercise for you. Think about it, okay? And then we're done. Let's say we talk about published book. Okay, maybe for your favorite science fiction or some novel, whatever, okay? So each published book has an author, right? Let's not talk about just the author specifically, right? Each author may publish more than one book, and also, now, should the author field or attributes be aggregation or composition? Before you guys share your thought, I can tell you that for this one, it's pretty open-ended. Not really a correct or wrong answer, but you want to argue whichever choice you might want to make. I can tell you, I can argue either way. Okay, for the author, should it be aggregation or composition? That'll be the last exercise we will do for this, and then we'll move on to a little bit of inheritance, a little bit. Ferrets. You think the aggregation? Why? Why the author should be aggregation?
Let's say the author publishes 10 books. All 10 books share his name. And then let's say they decide to change his name legally. All 10 books should be changed.
It's interesting in ferrets. Okay, let me ask you this. Let's say I got two. Let's say I got one physical book of the author, let's say written by you. Okay, let's say. It's a physical book with your legal name on the book. Let's say now you decide to change your name. Is the name of the author of that physical book going to be changed? Because it's on the paper, it's being printed already. If you change your name right now, is it going to affect that copy there? That would be how I will argue for composition. Depending, if you're talking about hard copy for the book, in that case, changing something after the book has been printed is not going to be of inference. So that will be composition case. Okay, just want to, but what you said was also right. I'll get to it. Marcus.
I was going to say it was composition because each book that he publishes, like if you just like say like 3 different books, each one has its own stuff inside the book. Like they're all different. Some of them share any attributes.
Mm-hmm. Yeah, for sure, yes. So composition is definitely more about the hard copy books. What about aggregation? Aggregation is also possible. Let's say if they decide to publish the book online. Usually for online, it's this really aliasing. Somehow, if you decide to change the, the author field is really referring to some single objects about the author's latest name. If you decide to change that latest name, it will be reflected to the web page directly, not like a hard copy. Okay? Anyway, so that's, let me show you the diagram over here. But as I said, it's a very open-ended problem over here. You can argue either way. What about composition? Composition would be, let's say we got two physical books over here, right? If, let's say, I decide maybe to publish maybe a second edition for this, but I want to update their name to somebody else. In that way, is it going to change this copy here? Not really, because it's been published already, printed. That would be composition. What about aggregation? Maybe these two books by the same author, they have been maybe published online. And their author field is simply referring to some remote or online storage. In which case, if you modify, for example, let's say here, this author name to be somebody else. In that case, it will be reflected in this book and in this book online. Right? So you can also argue for aggregation. So I would say either way is fine. Depends. So this open-ended question is something you will have to solve more often as a developer. You have to judge. All right? Alrighty. So that's about it for aggregation composition. Guys, any question for this? All right, and we're done with the aggregation composition. We still got about 15 minutes or so, so I'll definitely cover a little bit of inheritance, give you guys some feel. Okay? Before that, why don't we take attendance and take a little bit break? Okay. Get yourself ready, and then I'm just going to do some preparation here. Bear with me for 30 seconds. I need to refresh my location. Okay, 2030, and then I'm going to have view the course online. Yeah, just get your device ready. So as soon as I start the polling, you will be able to check in. Yeah, sorry, it's a little bit slow, but it will be there very soon. Okay, getting there. All right, I should go to settings. And then I should go to attendance. Don't require, require. So I can allow to refresh and save. Okay, done. And I'm now going to start a class and start a polling. And select. All right, you guys can just check in now. As usual, if you got issue, come over right away. All right. Oh, Marcus, that's a little bit surprising. Oh, okay. Okay, I see. Okay, go ahead, please. Just sign, and then, yeah. It's sorted by last name. Yeah, everybody else is okay? Make sure? Okay, good. Thank you. I'm going to stop it. And guys, take 2 minutes break. All right, we're going to start a brand new topic. I'll be with you. It's now 9:35 according to my watch. Let's resume 9:37. Okay? Don't go too far, please. So this line is calling another constructor, which is over here. We're just calling that. So this, in this context over here, is referring to the constructor in the same class. Right, that's what you're doing. Oh, guys, by the way, I also got some hard copy handout. I'm going to make the PDF available as well. If you want a hard copy, feel free to pick up one copy here. Okay, here. You can do it now or at the end, either way, but it's here. Yeah, we resume in 1 minute. Okay, we'll resume very soon. Yeah, just again, the hard copy here, you can feel free to pick up one copy for yourself. I'm also going to make the electronic copy available. But if you prefer hard copy, feel free. Okay? You can do that at the end of the class too. Okay. All right, let's resume. Inheritance. I have been talking about this big subject since day one. Now there you have it. Okay? We're going to spend at least 5 or 6 classes on this. 5 or 6 lectures on this, for sure. Inheritance is a very, very big topic. I think since this course is about advanced OOP, we definitely want to talk about it. We're gonna cover static type, dynamic type, extend keyword, typecasting, and also typecast exception. There are many subjects over there that we need to cover in detail. Also abstract classes, interfaces, polymorphism, dynamic binding. So these words come also very often if you go to the job interview if they ever ask you about Java programming interview. So I think it's going to be very beneficial for you. And for today, we only got about 10 minutes left. We'll definitely start more fresh on Monday next week for sure. I would suggest today, let's just get the context very clear. We're going to have a single running example throughout the whole inheritance lecture where we talk about any specific construct. Okay? And I want you guys to just look at, okay, so this just the learning outcomes. We're going to, before we ever talk about inheritance, we want to see what if you don't have inheritance? How bad is it? That's something will give you some idea as well. We're going to talk about static type, dynamic type. And one thing I want to mention, if you ask somebody, what's really inheritance in Java? If they tell you it's really about using the extend keyword to reuse the code, that's not a bad answer, but I would say that's only deserve about half of the credits. Code reusing using the extend keyword is only half of the story. The deeper story you ought to understand is about typing, data type. Right? That's something we have to focus more. Okay? That's something we'll get into, don't worry. And also static type, dynamic type, and also polymorphism, dynamic binding. Especially for polymorphism, we need to worry about different scenarios where it can happen. That's something we'll get into as we get more advanced in the lecture. Okay? And typecasting as well. Also typecast exception. That's also another exception that might occur very often in your code. So far we learned about array index out of bound exception, null pointer exception. So typecast exception is just the third kind. You ought to know under what circumstances can it happen. There will be some precise condition you have to know. All right, so just for today, I want every one of you just to be very clear about what the problem is. Can we spend 2 or 3 minutes reading over this description over here? This will be the problem we're going to use to solve using inheritance throughout all the lectures. Take a look at that for 2 minutes. And then we'll do a little bit of easy exercise, and then that'll be it for today. Next Monday, we're going to start fresh. Let me interrupt you a little bit. Think about what classes you want to create, and also what methods you want to create in each class. Also, what kind of attributes do you want to create, right? That's something I can also show here. That'll be the task, right? And if you recall what we said in the review lecture, in order to identify classes, you ought to search for some nouns in the problem statement. In order to create maybe mutator method, you ought to search for verbs, right? And some nouns might also be turned into accessors or attributes, right? Okay, I'll give you guys 1 more minute. It's so important to understand what the problem is, and I'm going to assume since starting from Monday, everybody at least is understand very well what the problem is. Okay. Okay, another 20 seconds, and then let's try to do a little exercise together. Okay. Okay, let me switch. The same description, right? Remember the principle that we set in the very beginning of the course. For nouns, some of them may be turned into classes, some of them attributes, some of them accessor. For the verbs, will be some of them mutators, right? Why don't we try? Okay, let's start with classes. Let me use green. How would you guys suggest which noun may be turned into classes? I'll go with you first. Yes. Okay, you're already saying extend. That's more about inheritance. I presume you might know inheritance already. That's okay. So you're basically saying we actually got resident students and also non-resident students. Apparently, they're the critical nouns. Maybe you wouldn't have attributes called resident students or attribute called non-resident students. So that it makes sense to have classes for them. I agree. Okay, good. And some of you might decide maybe student itself should be a separate class. So you may have students, resident students, and also non-resident students, 3 classes, maybe. Okay? And guys, by the way, I don't assume any one of you actually knows about inheritance. So if you know already, I'm pretty sure you'll learn something new very soon once I start talking about beyond the extend keyword. Okay? Anyway. Okay, so these, any other class you would like to create? Any other? Courses, I agree, thank you. That's very good. So let me look for course. Okay, anything else? One critical noun I would suggest. You're still missing one. Ferrets. I like that, exactly. Guys, I can tell you that the student management system is going to be the more difficult one to implement because think it conceptually. The student management system itself is going to store an array of students. But the problem is, if you got an array of students, let me sketch the idea very quickly. If you say this, let's say in the student management system class, you got a students array, let's say. But the problem is, each element in the students has 2 possibilities, either resident students or non-resident students. So far, you haven't really learned about a good way to handle this. So on Monday, what I will do is I'm going to present 2 poor designs to show to you how to get around with that. And then I'm going to criticize on them to tell you why they are bad. And then we're going to move on to inheritance. But student management system is definitely one class we cannot miss for sure. Okay, so that's about the classes. Guys, what about accessor? What kind of accessor do we need? Accessor, I can use blue. Okay, what about accessor? Yeah, go ahead. Tuition, I agree, absolutely. And I want to discuss tuition right away. So, for another tuition. And notice one thing here. This is also interesting. In order to calculate the tuition of students, there is not a single way to do it, depending on what kind of student we are talking about. If it's a resident student, you may need to apply certain rates. For non-resident student, you want to apply another rate differently. So that means tuition here, the complication is It depends on the kind of students. Right? That's important. All right. Okay, just 2 minutes, okay, and then I'll let you guys go. What about attributes? Anyone want to suggest maybe some attributes? Nay, I agree. I like that. Easy, but it's also critical. And I would say register courses, also important, right? Like an array of courses, for sure, absolutely. Anything else? Well, what about discount rate and also premium rate? I want you to look at these two. Again, it depends on what kind of student you're talking about. If you're talking about non-resident students, then discount rate would apply, but not premium rate. Similarly, if you're talking about resident students, then premium rate will apply, but not discount rate, like a one, but not both. All right? So that's the complication. Should not apply simultaneously. Simultaneously. All right. Today is a bit abnormal. I'll let you guys go earlier, okay? On Monday, we're going to start with developing 2 possible solutions for this problem here, criticize on them, and then we'll move on to programming inheritance, and we'll see how far we can go. But for the coming weeks, we're going to discuss inheritance. Get ready. All right, guys, work on your lab 3. Let me know if you got any concern. I'll see you next Monday.